About 4,000 years ago, the ancient Mesopotamians understood quite a lot about geometry. They understood the relationship between the perpendicular sides of a shape and its area. They also understood how to stretch one of these sides and the proportional impact that would have on its area. And they understood about Pythagorean triples. Now, why did they understand Pythagorean triples? What were they doing with these things? We know they understood them because of all their different educational texts, but what were they doing? What purpose did they serve at the time? To attempt to answer these questions, we're going to look at a very nice surveyor's document. This is Si.427 from the Istanbul Archaeological Museum. It was dug up in Separ in 1894, and it's one of the most remarkable and complete examples of applied geometry from the ancient world. Let's have a look at what it says. At the very top of the document, it talks about a certain area. I'll convert this into SAR, so this is 30, 45 SAR. It's written in area units, but I'll just convert everything to a standard area unit, which is a SAR. The numbers are in sexagesimal, so you can think about this number here as being, say, 30 hours, 45 minutes, but referring to an area. It says 30, 45 of marshy field, together with the tower and threshing floor. Great, so we understand immediately a little bit about what this document's saying. We're talking about some area of marshy field. Wonderful. Now, as is traditional, this surveyor has provided us with a schematic diagram of the field in question. You can see the irregular shape of the field has been broken up into different parcels, and these parcels have standard shapes. They're always rectangles, right trapezoids, and right triangles. Why? Well, because the area of these things is very easy to compute. Now, what's not usual about this plan, and what really stands out, is the degree of accuracy with which the surveyor has made those perpendicular lines. You can tell the accuracy because the rectangles are really rectangles. In a normal surveying plan, the surveyors just stood in the field and said, that looks approximately perpendicular to me, and then just made the lines. And of course, it's an approximation, so you get your rectangles, which look like rectangles, but they never quite have opposite sides of equal length. The surveyor who made this plan, however, nailed it. All the rectangles have opposite sides of equal length. As you can see here, there's a side of a rectangle, and there's another side of the same rectangle, and the area that's given here, or the length that's given here, is 50. Both sides. Opposite sides of equal length. Similarly over here. That side and that side. The length of both of these are given, and the length is both on either side is 22, 40. And again, 22, 40. I'll remind you this is sexagesimal, so think of 2240 as being something like 22 minutes, 40 seconds. We'll come back to that diagram in just a moment. Oh, before we do, this portion in here is an area. 18, 53 and a half. We'll come back to that diagram in just a second. Below the diagram, we see more text. It talks about, it speaks of a certain, the total area of the field. The total area is given as 4713 SAR. Total area of the field. And 6 26.5. Interesting. Now, this 4713, don't imagine that that's necessarily going to be exactly the total surface area of the field. It's just most likely an approximation. 626.5 seems a bit odd. That's much more accurate than we would usually bother to specify a SAR to. So it seems this region, whatever it is quite important. So we're starting to get a little bit of a feel for what this tablet's about. You've got some area of a marshy field, and that's part of the larger field. The larger field measures 4713. And for some reason, this tiny area of 626.5 SAR is important for something. We don't know what yet. Let's have a look at the rest of the diagram now. We've got a right trapezoid over here. That's a 640. That's 22. That length, that horizontal length there is, sorry, that vertical length there is 2240. And within it we see 5. Again, it's written in area units. I'm just going to convert everything to the single area unit of SARS. That's going to be 5, 24.5. Again, very, very accurate. The surveyor here, you can tell by the units. They're really going down to the fraction of a second here. 5 minutes, 24.5 seconds. They're really, really trying for accuracy. That really shines out from this tablet, even from the way the individual parcels of land are being measured. There's more. There's a 730 over here. And there's an 18 down here. You can really clearly read that 18. Partially you can read it down there. You only see the final 2 characters. You see most of an 18 down here. It's fairly clear that that's supposed to be 18. Up here we'll interpret that as 18 as well. And of course if you multiply by 18 by 730 and divide by 2, you get the area that's inscribed within this field. 107.5. That's the area of this little right triangle over here. Below that, unfortunately the area of this side down here is damaged. All that you can see is this remaining 10 over there. But fortunately we can reconstruct what is supposed to be written here, because we know that if you subtract 730 from 2240, what you end up with is 1510. So we think that should be a 1510. And of course, if you multiply 18 by 1510, you get 433, which matches what is written on the tablet there. Below, oh sorry, just to the left of that, you've got another right triangle. You can see a 610 over there. It's a little bit damaged, but still readable. You can see 40, that appears to be 46 something. We'll say that's 46.5. It looks like a half. It's hard to read, again, because of the damage. Below that, you've got this very, very long right trapezoid, like this. There's a 730 on one side. Helpfully, there's another 730 written over here. And if you take 730 and you multiply by the average of these 2 horizontal sides, what you end up with is 10 total. Exactly, which is what's written on the tablet, not just the area, but area total, because it's really the kind of amalgamation of all these different parts. And below that you see a very, very accurate length, 5, 42, 30. Now, the length up here is 730, so you think of that as being 7 minutes, 30 seconds. This one's 7 minutes, 30 seconds and a half a second. That's accurate. I don't know why they're doing it so accurately, but see, it's not clear at this stage, but at least the intention to be accurate is very, very clear. And if we again take this right trapezoid here with the horizontal sides, there's a 5 here, referring to that length. We'll take this horizontal right trapezoid, and the area inscribed within it is 708. Now the 708 doesn't exactly match what should be the area of this thing based on those measurements, so this might have been an error. It's unclear exactly what happened in this very final one, but at least the other ones we can be reasonably certain about them because they match up very nicely with what's written on the tablet. There's this funny 4. Why is that there? We don't know yet. Let's leave that 4 for a moment. Before we turn to the reverse of the tablet, we can start making sense of some of these numbers that we've seen so far. 3045 Sa of marshy field. That corresponds to this area up here, and we make the correspondence because if we add up all the areas of these shapes, we get 3045 almost exactly. Almost exactly, and nothing else really adds up even close to being 3045. So we can be fairly confident that this upper region here is the marshy region. We can also be fairly confident that we know where the 626.5 Sa is. That corresponds, again, by summing up the areas, to this region over here. Is part of this kind of sub-region of the marshy region. So this refers to the 626.5. Again, we don't know why this was singled out for special mention. We'll get to that. The 4713 Sa is very interesting. The total of the field, if we add up all these bits, is not quite 4713 Sa. As we'll see in a moment, this is not an error. Let's turn to the reverse of the tablet. The reverse of the tablet has a table of numbers. 2 columns, numbers here, then this large break, and then some text. The text reads, total surface area of the field, together with various marshes. Again, the marshy regions seem to be very important. Of Si.427. Si.427 is a renowned personage of ancient Sapar, which gels very nicely with the finding, the location that this tablet was dug up in. So we can be reasonably confident this is a tablet from Old Babylonian Sapar. The text goes on. Apart from 1140 Sa, again the 1140 is my conversion of the area units into a common unit to facilitate comparison with the other areas on here. It's actually written in a whole range of different Mesopotamian area units, and I'm just simplifying things for us. Apart from that much Sa, field apart from 1140 Sa field acquired through purchase. A little more of the story of this tablet is becoming apparent to us. We've got a field, some of it's marshy, and some of it is being purchased. A very familiar scenario from even modern day life. Let's look at this table a bit more closely. The table has a bunch of numbers on it. 18, 53, 20. Oh. 5, 24, 50. 1, 0, 7, 30. 433. 46, 10. And then there's an unfortunate break. We don't have any idea what, we can make an educated guess as to what would have appeared there, especially if you take those numbers and compare them to the inscribed areas on the obverse of the tablet. 185320 is exactly the area of that original rectangle, although it was written 18 minutes, say, as 18 minutes, 53 seconds, and a third of a second. The next one we looked at was 524 and a half. Here it appears as 524.50, but 524 and a half is the area that was inscribed. There's probably been some kind of rounding going on here. 10730, again, exactly on the nose, the area that was in that little right triangle up the top. Similarly with 433, the area of that smaller rectangle. 4610, well, it appeared to be 46 and a half on the tablet, but it might have been 4610 because of the break. It looked more like a half. So we'll say it's a half on the tablet, on the obverse. Now, these lines down here might have contained the area of those two large right trapezoids. That would make a lot of sense because those were the final two objects on the plan, and there seems to be a kind of top to bottom flow going on here of these numbers. So it would make sense that the final bottommost two shapes would have been the bottommost two rows of this original tablet, of this original table. Now, this is interesting because all the inscribed areas have now been accounted for. So what's this other side of the table doing? Let's have a look at what the numbers say. 6, 0, 3, 55. 28, 44, 8, 30, 45, 1, 0, 7, 30. Well, at least that one's familiar. The others are a bit strange. We haven't seen those before, but the 1, 7, 30, we recognize that one. 51, 35, 30, and 1, 0, 5, 37, 30. What could these be? Let's go back to the obverse of the tablet and see if we can figure out what these are. The first column of this table were areas from this kind of top to bottom horizontally oriented survey of the field. That suggests that these numbers over here are also areas, although of a different kind. Here we are back again at a fresh copy of the obverse of the tablet. Now, we were able to make sense of this one here. That's an 18, that's a 730, 107 and a half. So we've seen that one already, half being half a second, or 30 in their sexagesimal number system. What else can we make sense of here? Well, if we take this region, as a rectangle with base 18, and we just use the heights that we've obtained before. Remember, this one's going to be 1510. That's a 730, and that's 542, 30. So those measurements there. If we add all those up and multiply it by 18, we get 8, 30, 45. On the nose, 8, 30, 45. Ooh, that's familiar from the reverse. That was the item in column 2, row 3. This is the item in column 2, row 4. So from those two, it suggests we've got a vertically oriented survey of the land. We're looking for areas, and these two appear to be from a differently oriented survey of the same piece. Let's try this one over here. This appears to be on the field, on the survey, a right triangle. If we take one of these measurements, like that, and then a diagonal like that, and if we take a 22, what was it? It was just 22. And over here we have a 22, 40. Remember there was a 640 here, and there was a 5 there. That's 730. Now, if we use the 542.30, the original measurement down the bottom, we don't quite get the area we're looking for. However, we do get the area exactly 603.55, provided we use a new length for this thing. 255. Now, you might say, well, that's very bold of you to change the numbers written on the tablet. There's very good reasons why we might want to change that number. The first reason, 255 actually brings this right triangle in alignment with these other two numbers. Using a 542.30 is actually too long there. It wouldn't make this into a real right triangle. Second reason, well, okay, it makes the right area. Third reason, if we assume that is a 255, then we get the area of this, it would be a right trapezoid with height 50. These two vertically oriented parallel sides would have different length. It gives us 28.44. Not exactly, but really, really, really close. Much closer than using that original length would do. So it seems like the surveyor used a different length, most likely 255, to obtain these two areas. These two areas both require an area, a length of 255 down here. So they kind of complement the notion that this length here is, the length that was used there is actually different in the vertically oriented survey. Now remember, in the horizontally oriented survey, the surveyor had to keep these two sides parallel. That's just the nature of the way they were making the survey. They don't have that restriction when they're doing a vertical survey. So this length now has to be parallel to this, but they can be of different lengths. And so it seems like the field was genuinely shorter on this side, and the surveyor used the genuinely shorter length to measure it. And the fact that this right triangle, that aligns with these other two data points here, is further evidence to suggest that's what's happened. Good. The final two numbers are more difficult to render because there was probably some kind of arithmetical error in here. We're looking for two numbers, 51.35.30 and 105.37.30. Very, very detailed. They have to squeeze in here somewhere. The best guess is that it went this way. That the field, well, it's drawn like that, but it's more likely that this is actually two right trapezoids oriented this way. The 4 that we didn't use earlier is the width of one of those right trapezoids, and the remaining 210, I'll do it in red, 210 being the width of that right trapezoid. Now, even under this assumption, you don't get the areas exactly. My best guess as to what the length of this was is 19, 30, 6, 15. Now, if you use these measurements with the 4 and the measurements given on this left-hand side and 19, 36, 15, then you're able to obtain the final area, the 105, 37, 30 exactly. Now, unfortunately, if you use that same measurement on this little slither, you don't get the right area. But if you use 19, 15, you do. So my hypothesis is that the scribe used this area is in fact its length is in fact 19, 36, 15, but that the scribe forgot 36 when they made that final calculation. Again, it's a hypothesis. I'm not exactly sure how they managed to get that final area. Perhaps they just made some computational errors. It's hard that are beyond my imagination to reconstruct. Coming back now to the original obverse of the tablet, we're starting to see more and more of the complete picture. The amount that was purchased, that 1140, if we use the measurements of not the horizontal but the second vertical survey, then this region over here corresponds almost exactly to the 1140. In other words, this is the purchased. And now the complete story of the tablet is apparent to us. There's a field to be sold. 3045 of it is marshy. This side of it over here, roughly measuring 1140, is being purchased. And the reason why this 626.5 is so important and gets prominently mentioned is because this is the amount of the marshy field that was part of the purchase. This total, 4713, is not the total of the horizontal survey. It's not the total of the vertical survey. It's the average of the two totals from the vertical and horizontal surveys. So the surveyor thought this field was very, very important. They measured it very precisely, which you can see from the accuracy of the measurements, the accuracy of the perpendicular lines, the fact that they bothered to measure it twice and take the average. It's a very, very, very accurate survey. So now that we have this picture of what the tablet says, let's dig a little bit deeper and ask ourselves, how? Surveyors at the time were armed with measuring rope, a measuring rod, and an education in mathematics. How could someone using only those tools construct such a precise survey? The answer lies at strategic locations within the field. If we look closely here at this rectangle, this rectangle has this very central and prominent position, giving you the boundaries of the marshy area, which is important to the surveyor, and this new boundary that separates the purchased field from the original field. This is very important. It's very important for the surveyor to get these two things correct. And the way they do it is by taking what's called a Pythagorean triple. So in this case, 18 units that way, 7.5 that way, and 19.5 across the diagonal makes a mathematically perfect right triangle, or in this case, rectangle. The sides of this rectangle can then be extended by sight to give you that boundary there, and this boundary here, as well as that one there. There's another Pythagorean triple up here. It's in fact the same, with the same proportions, but this time as a right triangle. Again, 18, 7.5, 19.5 would be the diagonal there. This one was probably chosen because its slope roughly matches the slope of the field here. And it produces, again, right angles. Maybe this was originally a rectangle and maybe it was originally used to provide this line perpendicular to this line, or maybe it was simply used to ensure this line was perpendicular to this line. We don't know. And the third Pythagorean triple that occurs on this shape is actually here. If we take that 4 and that 730, then this shape here becomes a Pythagorean triple. This one is not the same dimensions or proportions as the 5, 12, 13. This is the 8, 15, 17 Pythagorean triple. And again, you can see why a surveyor might want to have put a Pythagorean triple here in order to ensure that this boundary between the marshy field and the rest of the field is actually perpendicular to the other boundary of the purchase field. So we can see the emphasis on accuracy everywhere through this plan. It's apparent in the measurements, like this measurement down here, 5:42.5, 5 minutes, 42 seconds and a half a second. That's so accurate for the time. That is reflected again in the way that the areas are specified. Normally a surveyor wouldn't even bother to specify units less than a SAR, but this person's gone 1853 and a third of a SAR. And third and foremost, this emphasis on accuracy is reflected in the perpendicular lines themselves. The fact that the surveyor has gone to the trouble to use Pythagorean triples to ensure the perpendicular lines in this plan are as accurate as they can possibly be. This makes Si.427 one of, as I said before, the best and most complete examples of applied geometry from the ancient world.